Hey everyone, and welcome back to this class, Artificial Intelligence, Reinforcement Learning in Python. In this lecture, we are going to implement epsilon gradient code and demonstrate the effect of different settings of epsilon. If you don't want to try to code this yourself, although I highly encourage you do, the relevant file in the course repo is comparingepsilons.py. We start out with the bandit class. The constructor takes in one parameter m, which is the true mean. We set the instance variables mean and n to 0. The mean instance variable is our estimate of the bandit's mean. Next we have the pull function, which simulates pulling the bandit's arm. As you can see, every bandit's reward will be a Gaussian with unit variance. Finally, we have the update function, which takes in x, which is the latest sample received from the bandit. Notice the update equation we just discussed. Next, we have the run experiment function. It takes in three different means, m1, m2, and m3, since we're going to compare three different bandits. It takes in an epsilon, so we can do epsilon greedy, and it takes in n, the number of times we play. When this function returns, we want it to return an array containing the cumulative average after every play, and we are going to compare these plots for different settings of epsilon. We'll keep our results in an array called data of size n. Notice our implementation of epsilon greedy inside the loop. We generate a random number p between 0 and 1. If p is less than epsilon, we choose a bandit at random. Otherwise, we choose the bandit with the best current sample mean. We pull the chosen bandit, and we update the bandit with the reward we just got. Then we save x. When the loop is finished, we calculate the cumulative average. When that's done, we plot the cumulative average along with bars showing each of the means, so we can see where our cumulative average is relative to those. We do this on a log scale too, so you can see the fluctuations in the earlier rounds more clearly. Finally, we print each of the estimated means just for debugging purposes. In the main section, we do the same experiment 3 times, each with a different epsilon, 10%, 5%, and 1%. Next, we plot the cumulative averages together. We do both a log plot and a linear plot, since with the log plot, all the later data is squished to the right, so it looks like we spend more time being very suboptimal than we actually do. Now let's run this and see what we get. Okay, so this is with epsilon equals 0.1. This is epsilon equals 0.05. And this is epsilon equals 0.01.